How's it going, everybody? So today we're going to be talking about inequalities, and more specifically non-linear inequalities. And the idea is that this is going to encounter the shading process. We did this with the absolute value, and if you remember, it incorporated the less than or greater than, the less than or equal to, greater than or equal to, and depending on where the arrows were pointing, it told us where to shade. Now, that was back when things were a little bit easier and the arrows did tell us where things were going to be shaded. Unfortunately, now we have met a process with nonlinear systems where we cannot just count on that working. We actually have to test on the number line where the statement is true. I'm going to show you how to do that right now, so make sure you pay close attention on graphing non-linear inequalities. Now, we will eventually graduate from just a number line to an actual graph, which will incorporate a system of nonlinear inequalities, which will then tell us where solutions are located based upon where the region of the colors meeting match up, okay? So eventually we'll graduate from this and move to that, but for now we're going to stick with the basic. Let's talk about this. Say I have x squared plus 2x minus 3 is going to be greater than 0. So looking at this particular problem right here, you'll notice this is set up in a format that we can actually factor using the AC method, because we need to find the values of x on the number line, the intercepts, so that way we can go ahead and figure out where we got to shade, okay, in relation to them. So we're going to do the AC method here because I got my ABC. The AC that I see is going to be a -3. And of course, the things that add up to a +2 would be a +3 and a -1. Because the idea is that when multiplied, still gives you -3, but when added, it'll give you 2. So when you break this apart, you have 3x minus x minus 3 equal to 0. You'll notice I switched the inequality greater than to an equal sign. That is for the purpose of solving for the value of x. We will rectify the issue and bring in the inequality in a later time, okay? Now, looking at this right here, we're going to go ahead and split this down the middle, okay? And so this right here, we're going to take the x out, and we're going to have x plus 3. What you get on one side, you should get on the other, so x plus 3 will come back. And what's in front of the factor is going to be a -1. So we would have x plus 3, x minus 1, and that's equal to 0. Now, solving for these, you put your factors equal to 0, but I'm going to anticipate you know that, and this would give you a -3, and this would also give you a +1, okay? So these right here are the locations of the x-intercepts for this particular quadratic. Now, the number line, let's talk about it. We're going to go ahead and put our numbers on there. We have -3, we have +1. The first thing when it comes to the inequality, bringing it back, okay, the greater than symbol, it tells us what kind of circle we're going to have at that particular point. So since it is just a greater than symbol, it's going to be an open circle. Had there been a line underneath it, that indicates a closed circle. Now, we're going to figure out where we're going to shade. Now, this is going to feel a lot different than what we're used to. Typically, we would look at the arrow and it would tell us shade left, shade right, but that's not a thing anymore. Unfortunately, we are now going to have to test individual x values in between or outside the numbers. Now, I'm going to tell you this. My preference is I always, if given the opportunity, like to test the x value of 0, okay? 0 is located right here in between -3 and 1. Now, the reason I like testing 0 is because I have to plug the number I'm testing back into the original equation with the inequality. So I have myself a 0 squared plus 2 times 0 minus 3 is greater than 0. Now, looking at this right here, ladies and gentlemen, the idea is that I'm going to determine at the end of simplifying, is this a true or false statement? If it ends up being a true statement, I'm going to shade where my point is located. If it is false, I will shade away, okay? Not in that area or region. So let's go ahead and simplify. So 0 squared, 0, 2 times 0, 0, leaving you with -3 is greater than 0. Now, you can see why I choose 0. It basically makes your math really easy. Anything with a 0 in it goes away, leaving you with purely the constant to look at. Now, determine, is this true? Is -3 greater than 0? The answer to that is no. This is a false statement. So since this is false, okay, this region right here, we are not going to shade in between the numbers, but rather we're going to shade on the outside, away from it. So the idea is that if we had been true, had that statement worked out, then we would have shaded inside, okay? But just to kind of solidify maybe this thing I'm trying to communicate, let's test this number 2 over here, okay? The idea that I'm communicating is that this should end up being a true statement, right? If that 2 is shaded, that's going to be true, so let's test it. Now, I won't recommend that you do this all the time. I'm only doing this right now. Typically, I only test 0 and I move on. So here I'm going to have 2 squared plus 2 times 2 minus 3. And let me go ahead and shrink you down so I can put your inequality there, is greater than 0. So 2 squared is 4. 2 times 2 is 4. Minus 3 is greater than 0. Well, that's going to give me 8 minus 3, and 8 minus 3 is 5. Now, is 5 greater than 0? Yes, this is a true statement. And so since we notice that it's true, that's why we shaded right over here. Okay, that's why you see it bolded in red. Now, opposite of the -3 over here, the same thing would occur if you chose maybe something like a -4. Okay, the same thing would happen. You would notice that -4 would also be a true statement. And you can test that if you'd like to, and you'll hopefully come to that same agreement that I have. Now, let's try another example. So let's try this one. So we have ourselves a x squared minus 4x plus 3 is less than or equal to 0. Now, we're first going to do the AC method on this because I noticed, that's what I could do. Some students have asked in the past, could I do the quadratic formula? You bet you could. You could do the quadratic formula. You could do completing the square. The idea is that you're just trying to solve for x-intercepts. So use the tools that you have to get to that answer. So I have x squared minus 4x plus 3 is equal to 0. I'm going to go ahead and do that. Now, doing the AC method, you'll notice that you'll have a 3, but you need it to add up to a -4, so that would be -3, -1. So you have x squared minus 3x minus x plus 3 equals 0. So split it down the middle, and you end up with x minus 3. And then, of course, x minus 3 will end up over here with a -1 in the front. You'll have x minus 3, x minus 1 equals 0. So x is going to equal 3, and x is going to equal 1 after you put them equal to 0, okay? These represent your x-intercepts. Now, the next thing is the number line itself. So we're going to put 1 and 3. Now, at these numbers, you're going to notice that we have a less than or equal to symbol, which requires a closed circle, okay? Closed circle. And it is because of the line underneath it. Now, I like to test the number 0. The number 0 is located over here. And so the idea is that if it ends up being false over there, I'm not going to shade on the outside, but rather I will shade inside, okay? And excuse the bell, guys. I apologize about that. So let's go ahead and test 0. So I'm going to plug it into the original equation with the inequality. I have 0 squared minus 4 times 0 plus 3 is less than or equal to 0. So ends up being 3 is less than or equal to 0. Now, is that a true statement? Is 3 less than or equal to 0? And that's not a true statement. That is false. 3 is greater than. So since this is a false statement, I'm not going to shade outside. I'm going to shade inside. Now, you could, if you definitely like that peace of mind and you want to really solidify this understanding, you could try 2, because 2 exists in between 1 and 3. And looking at this right here, you could go ahead and say, alrighty, let's do 2 squared, and let's do minus 4 times 2 plus 3 is greater than or equal to 0. So 2 squared is 4. Negative 4 times 2 is negative 8. Then we got plus 3 is less than or equal to 0. Well, combining terms and stuff, we've got ourselves a negative 1 when you combine all that. Now, is negative 1 less than or equal to 0? Yes, it definitely is. So this is a true statement. So since it's true, that's why we shaded there, okay? So hopefully you're starting to buy into the idea of checking your answer in between and outside, and especially checking just 0. Checking 0 is the easiest way to go. Some of you may have already been developing the idea that if I'm just plugging in 0, that means all I'm really checking for is, yes, the constant. And if that's how you want to think about it, that's beautiful. That works. Whatever floats your boat. Now let's try one more. Say you were given something like this. 0 is less than or equal to x squared plus 5x. So this right here, you could definitely do the AC method here, but there's a special scenario where the C value is 0. You could automatically just begin factoring out the x that they have in common. And so this would give you x and then x plus 5. Now, we would once again say where the x-intercepts are. They're at 0 and at x equals negative 5. Now, putting this on the number line, I've got myself a 0, negative 5, and then 0 over here. Now, typically, I like to use 0, but unfortunately, 0 is what I'm using for the number line, so I'm going to need to choose a different number. So before I do that, I will need to go ahead and put that these are going to be closed in circles because of the line underneath it, okay? So now I'm going to choose a number that's relatively easy for me to test. I'm going to choose a 1. I think 1's easy, so I'm going to try this number. So I've got 0 is less than or equal to 1 squared plus 5 times 1. So that means I have 0 is less than or equal to 1 plus 5. 1 plus 5, that is 6. And so is 0 less than or equal to 6? Yes, that is true. And so since that is true, I will shade over here to the right-hand side and to the left side. I will not shade in the middle because if you start shading on the outside, that of course will stay outside, okay? You won't shade outside and middle, okay? If it's outside, it'll stay outside. If it's inside, it will never go outside. So that right there is what we're doing today for this assignment, being able to shade and tell where our solutions are going to exist on this number line. So remember, this area over here is where your x value exists that satisfies the given inequality. Thank you guys for your time, and let me know if you need anything. Good job.